Opening scene, a starry night sky, camera pans to a satellite glinting above Earth, mysterious music fades as the narrator begins. What if I told you that in 2017, a particle of light vanished from Earth and reappeared in space? Not through a rocket, a wormhole, or magic, but through a phenomenon so bizarre even Einstein called it spooky. This is the story of how scientists teleported a photon 310 miles into the cosmos, and why it might change. Scene transitions to a montage of scientists working late at night, lasers firing into the sky. Let's rewind. In a remote corner of Tibet, a team of Chinese scientists huddled in a lab perched 2.5 miles above sea level, higher than most clouds. Their mission? Crack a code nature had kept secret for 13 billion years. Quantum entanglement. Cut to animation of two photons spinning in sync, then separating across Earth and space. Here's the deal. Quantum entanglement links two particles so deeply that whatever happens to one affects the other, no matter the distance. Imagine tossing a coin in New York, and its twin in Tokyo lands the same side up. Every single time. Freaky, right? Cut to archival footage of Einstein looking pensively at a chalkboard. Einstein hated this idea. It shattered his rule that nothing moves faster than light. But in 2017, China's Micius satellite proved him wrong. Let's break it down. Scene shifts to a split screen. Earth lab on one side, satellite on the other. Arrows show photons moving between them. Step 1. Scientists entangled photon pairs on Earth. One stayed behind, the other rode a laser beam to Micius. Step 2. They read the quantum state of the Earth-bound photon, and like a cosmic game of Simon Says, the photon in space mirrored it instantly. No wires, no signals, just cut to a person materializing in a sci-fi transporter beam, then dissolving into particles. Now this isn't Star Trek teleportation. You're not moving matter, you're copying. Think of it like emailing a blueprint to Mars, where a printer reconstructs you atom by atom. But here's the million-dollar question. If a perfect copy of you appears on Mars, is it still? Cut to an ancient ship sailing into a storm, then docked with workers replacing its planks. Enter the ship of Theseus, a 2000-year-old thought experiment. If every plank of a ship is replaced over time, is it the same vessel? What if we applied that too? Your Martian twin has your memories, quirks, and Netflix password, but your original body, still on Earth. So, who's the real you? Camera lingers on a person staring into a mirror, their reflection morphing into a stranger. Philosophical nightmares aside, let's talk real-world impact. Micius wasn't just a party trick, it laid the groundwork for Imagine unhackable communications, computers 1,000,000 times faster, and data traveling instantly. No more buffering, ever. Cut to a futuristic city with data streams zipping through the air. And the race is heating up. Last year, scientists hit 90% teleportation accuracy, even in noisy cities. German researchers piggybacked quantum data on regular internet cables, like sending a whisper through a rock concert. The best part? It works. Scene shifts to a hacker trying to intercept a data stream, only to be blocked by a glowing quantum shield. But quantum links are fragile. Micius needed Tibet's thin air to avoid interference. Today, engineers are building quantum repeaters to stretch these connections across continents. Soon, your phone might run on a network even Schrödinger couldn't explain. Closing scene. The satellite Micius orbits Earth, sunlight glinting off its panels. So, are we on the brink of teleporting humans? Not yet. But every photon beamed into the void pulls us closer to a future where distance is meaningless, secrets are unbreakable, and the line between science and fiction blurs. With that said, thanks for watching, and until next time.